Welcome back. We're on chapter 10, which is going to be covering probabilistic reasoning. This is probably the most important chapter for understanding statistics and for understanding events out in the world and understanding the degree to which they affect us as individuals. So let's begin. So let's start with a nice dice game. I tried to create a die where we have a red side that's facing us. We have green all around the four other sides. And then the back of the dice would also be a red panel. So you've got two red sides and four green sides on this one die. So you're offered a bet. You will be paid $25 if you correctly predict the sequence of colors that will be rolled by this die. Which pattern is more likely? Red, green, red, 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 or green, red, green, red, red, red. All right, so you want to pick carefully because if you pick the correct sequence, you get $25. We all recall that whenever I offer you money in this class, it's pretend money. So which pattern is more likely? So a lot of times people are attracted to the green, red, red, red. But the problem with being attracted to that one is that you have a better probability of being correct when you predict a 5 sequence string than in predicting a 6 sequence string. And really the only difference between the pattern on the left and the pattern on the right is the additional green in the front of the pattern in the one on the right. So why are my students so often attracted to the green? And I'm only speaking about my face-to-face experiences, that they tend to want to pick the one on the right. And the reason is that there are more green panels on the die, and so it makes them think that the pattern that contains more greens would make more sense, that it would be more likely. We're sort of thinking probabilistically here, right? If we have 2 reds and 4 greens on the die, the probability is that we would come up with a green twice as often as we would come up with a red, right? And especially over the long run. If we rolled this die 100 times, we would expect to find that, 2/6 of the time, or 1/3 of the time, it would come out red, and 4/6, or 2/3 of the time, it would come out green. And across the long run, that is absolutely true. One of the things that we need to remember when we think probabilistically is that over the short run, 5 die tosses or 6 die tosses, the pattern doesn't necessarily represent the proportions correctly, right? You can get a random pattern that doesn't represent the larger ultimate pattern. So there are a couple of faulty reasoning issues that go into us selecting the right-hand pattern over the left-hand pattern. We are incorrectly applying probabilistic reasoning to a very short string of events. And we're ignoring the fact that the left-hand string is actually included within the right-hand string. And so surely the shorter string would be the one we should always pick. Okay. Hopefully that got you set up for sort of thinking about probabilities and things like that. Now I'm going to introduce a couple of things that interfere with us being able to think probabilistically. One is our tendency to focus on miracles, or what the textbook calls person who statistics. Oh, I know this person who, right? I know this person who had this happen to them. And so now, because I have a concrete example, that event is more likely than what the statistics tell us it should be. This is falling under the category of a miracle. So I'm going to give you some examples of what I mean by miracle. This made the rounds of emails back right after 9/11. They showed us a series of folds that we could do on a $20 bill, and then it says, had a whole bunch of sort of ominous messaging included in the email, and it finished with, what are the odds that a simple geometric folding of the $20 bill would accidentally contain a representation of both terror attacks? Well, given that you folded a $20 bill and I can see what you're looking at right there, I'm going to have to say the probability, the odds are 100%. Right? Like, what are the odds? I'd say the odds are, 1 to 1. Perfect. Now, of course, what I'd like us to look at is, given that folding of the $20 bill, I put a picture. This picture of the Twin Towers burning was not provided in the email. I provided it for us. Is that really a representation of the Twin Towers burning? I think you got to use a little bit of creativity to see it like that. It could very easily flip it the other direction, look like a rocket taking off, right? It can look like a lot of different things. I think in the aftermath of 9/11, it was just that people were predisposed to see it that way. And then you'll notice that the question that I lifted here, it actually says a representation of both terror attacks. If you fold it a different direction, you get what appears to be the Pentagon burning, but only if you really are super creative in your interpretation of what the Pentagon burning looks like. So what are the odds? Well, 100%. How about this miracle? Doctors said I'd never walk again. After her quad bike accident, surgeons believed Charlotte Powell, 24, from Worcester, would be in a wheelchair for life, but she proved them wrong. I emphasize those final words for you. So the doctors said that she would never walk again, but she proved them wrong. It's a miracle. Breast cancer survivor delivers miracle baby. Right? She lost her breasts and hair to cancer before she was 30. She refused to lose her hope of motherhood, and she ultimately had a baby. It's a miracle. The fact that we characterize unusual things or events that seem to fly in the face of probabilities, the fact that we label them as miracles or we make them seem like ominous, meaningful events, like in the case of the $20 bill there, the fact that we do that means that we overemphasize the importance of these events and ignore the true probability that that event was going to happen anyway. The fact that the $20 bill, when folded in certain ways, might look like the Twin Towers burning, for one thing, the probability of that happening goes up when you have just had an event like 9/11 and people are predisposed to see very ambiguous things as examples of the Twin Towers burning in the case of what we're looking at right now. If you've been told that the probability is really low that you're going to walk again after your quad bike accident, you can imagine that you might hear that as you're never going to walk again. The probability was probably low, right? The doctors probably told her it's unlikely that you're going to walk again. I wasn't there at the doctor's visits or anything, but what she heard was that she'd never walk again. The fact that she is walking again makes her feel like she proved them wrong, when probably they didn't say you'll never walk again. They probably said it's unlikely. And what they made was a probabilistic statement. Of 100 patients with this kind of damage that you have, maybe 15 of them might walk again. So we're going to tell you that it's unlikely. Maybe 5 of them would walk again. So it's unlikely. But guess what? 5 of them have walked again. So is it a miracle? Or is it the other side of the probabilistic statistics? Just like a die with 4 green sides and 2 red sides can come up red every time in a string of 5 rolls. Doesn't make that a miracle. It just means that it's on that side of the probability. If it did 5 red rolls, probabilistically, if you did another 20 rolls, you'd end up with more of them being green, right? Because statistically, that's how it works out over the long run. So over 100 people who have had this kind of breast cancer treatment, maybe 3 of them were able to have children afterwards. That doesn't make the fact that she had a child a miracle. It means that she was in the smaller subset. And that's the trick that we often, the problem that we often display is that we focus on the wrong part of the statistic and think, okay, so if 97% don't have babies, if I have a baby, it's a miracle. Instead of hearing what it is, which is it's just the unlikely side of it. This also went around in emails. Back in the old days, before the invention of memes on, social media, people used to pass this stuff around as emails. And this one came around and it was captioned "Brothers from Another Mother" is how it was captioned. I'm pretty sure that this cat and this rabbit aren't actually related to each other, but it was just a series of animals with the same kind of fur pattern across species. And of course it was supposed to be, wow, look at this miracle of how these animals look exactly alike, even though they aren't the same species. But what I was thinking as I was going through them all is like, wow, that's a really common fur pattern. A lot of different animals have similar fur patterns. I mean, we could probably line up, cats and rabbits and goats and all sorts of creatures that have this exact kind of fur pattern. It's a very common one. Is it a miracle? No. It's just, kind of fun to see. I'll give you that. It's kind of, cute to see a kitten and a rabbit with the same fur, but it doesn't mean that it's like, ooh, it's a miracle. Brothers from another mother. I don't think so. How about this one? This one came around with a caption that said something like, this our construction company even hangs the moon or something. Now, of course, this is not a miracle that it would look like this crane is hanging the moon. It's something that would happen given, clear skies and everything, every 28 days, basically. Slightly off because the moon kind of takes a slightly different trajectory. But the thing is, this is not a magical thing that we're witnessing here, seeing a crane looking like it's hanging the moon. This is something that would happen very predictably. If we were good astrophysicists, we'd be able to calculate how often, if this crane stayed in exactly the same position, how often it would be able to take this exact same picture. So the fact that we don't know what those numbers are doesn't make them miracles. It just means that, it's a maybe a complicated formula to compute, but it is computable and it is knowable. And so it's not a miracle. All right, so now that we've covered a couple of, odd things that I've seen in emails and stuff over time, let's apply what we've been talking about to some actual psychological findings. So for example, this first one, couples who live together before marriage are more likely to divorce. And so I provided the citation for you at the bottom in case you want to look any of these things up. What I did was I pulled a few topics that I thought would, at least one of them, make each individual one of you say, I'm not sure I'm buying that. So this one might be one that you're like, I don't know, my significant other and I lived together before we got married and it worked out fine for us. Or maybe I'm living with my significant other right now and we're planning on getting married. Like, I'm hoping that it's for some of you making you say, I'm not sure I'm believing that. Okay, so in case you're not in that category, let's give you another one. Girls raised by stepfathers start menarche earlier. So menarche is having your first period. So girls raised by stepfathers reach menarche earlier. Okay, if you were raised by a stepfather or you are a stepfather or something, hopefully it's making you, this little finding is making you say, I'm not sure I'm buying that. I gave you the citation so that in case you really aren't buying it, you can go read these papers. Boys who play violent video games are more aggressive. Okay, now I'll bet that there are a lot of people in the class who are like, I'm not buying it. My son being one of them. And I'm not entirely buying it, frankly. This is one that gets me because I'm like, not sure I'm buying it because I have a 24-year-old now son who plays lots of violent video games and he is not aggressive. So in fact, sometimes when he was wrestling, we were wishing he was more aggressive. So hopefully with these three that I just pulled, I tried to pull ones that are, in the first two, when I teach human sexuality, those are ones that get big reactions out of my students. So I pulled those two. And then my son had just been doing a report on violent video games. So I thought, I'll add that to my list. So I pulled a few. Hopefully I've hit on something that each of you is sitting home thinking to yourself, I'm not sure. I need to see that data because my experience is different from what these little blurbs are describing. So as you sit in that feeling, I'm not going to try and break down these studies. What I want you to think about is this larger concept idea. It's possible for the study's data to be accurate and for your experience to be accurate and for them not to match. Because when we look at, let's just use couples who live together before marriage. Okay, when we look at that, we see on average a higher risk of divorce among people who cohabitated before their first marriage. So that means there are a lot of people who cohabited who by the time of the study and after however many years or whatever they'd been together still had not divorced, right? And are probably never going to divorce. There are people who did not live together before they got married who have divorced by the end of the study, right? Or who are going to get divorced by the within years. So we're looking at some of the couples who cohabited not performing as described in this blurb. Some of the couples who didn't cohabit not performing as described in this blurb. But the bulk, the majority, following this pattern. So we need to think about it like the person who had the quad bike accident and was told she'd never walk again. Well, she probably wasn't told that. She was probably told it's unlikely. More people don't walk after this kind of accident than do. More couples who cohabit before marriage get divorced than those who don't cohabit before marriage. Girls who were raised by stepfathers, on average, start menarche earlier. I didn't pull this an older study because I kind of wanted to pull new ones for this recording. But a previous study that I had used as an example actually showed that they compared sisters. They compared sisters. The older sister reached menarche while her parents were still married, and the younger sister reached menarche after mom remarried. And that was an interesting, that was complex to populate that study. And what they found is that the older sisters reached menarche older than the younger sisters did. So that was almost like getting pretty close to having some pretty good control in that study. I also, just in full disclosure, found a study from Australia that was published in the last couple of years that was trying to provide evidence that undermines this association between stepfathers and menarche. But the reason why I didn't pull it is because it had the world's most complex and convoluted multiple regression analysis that I thought made it looked a lot like they were sort of manipulating the data through the use of the statistical analysis, so I didn't like it. But the idea that on average we see a particular pattern means that there are people who are going to be outside that average, right? So while it's possible that in the ways that they measure aggression in research, boys who play video games and then immediately thereafter are given the opportunity to behave aggressively, they do it more commonly after playing a violent video game than they do after playing a non-violent game. That doesn't mean that every boy who plays a violent video game will behave aggressively in all circumstances or even in the circumstance provided in the study. A lot of times, just full disclosure on that one, a lot of times they use stand-ins for aggression because it would be very unethical for us to conduct studies where we let people actually aggress on other people. And so they have a variety of different ways that they measure aggression or behaviors that they use as aggression. One is to give the boys, after they played the violent video game, an opportunity to play another game against what they think is an opponent who's in another room. The truth is they're just playing against a computer that's in the other room. But if they score higher or first or whatever, they get to blast their opponent with really loud white noise in their what they think is their opponent's headphones. And the reason why they think it's really happening is that sometimes when they lose, they get blasted with white noise in their headphones. And what they found is that boys who have been playing violent video games turn that white noise up louder than boys who have been playing non-violent games. Another way that they measure aggression is to have the player dole out into a shot glass an amount of Tabasco sauce that the other player, who again is imaginary in the research, the other player is supposed to drink however much they dole out in the shot glass. And they think it's real because periodically they lose and they have to drink the shot glass of Tabasco that they think was doled out by their opponent. And what they find is that boys who have been playing violent video games dole out more Tabasco than people who have been playing nonviolent video games. So hopefully I've explained each of the studies well enough so that you're like, well, I guess I can kind of see what they're talking about anyway. But the overarching message that I wanted you to get from these is that, it's completely reasonable for an individual to be different from the overall pattern, right? That's completely reasonable. That if we say the typical player did this, or the average girl raised by a stepfather had that, or the most common couple who cohabited before marriage had this outcome. That's completely reasonable for us to talk about patterns, and for an individual to be in the outlying, atypical part of the study. Completely fine. So hopefully that all makes a lot of sense. Now what we're going to do for the rest of this whole chapter really is focusing on a bunch of thinking errors that make it even harder for us to think probabilistically. So one way that we make mistakes is we project what we know onto other people. So that manifests itself in lots of different errors. So if you guys are at all familiar with Freudian theory, one of his defense mechanisms is projection. And in his model, the things that we think or feel that we feel uncomfortable about, we will often project them onto other people and pretend to ourselves. We'll try and convince ourselves that other people feel or think that way. And that way we can kind of defend ourselves against it and stuff. It's all a beautiful mechanism. In this particular term, projective way of knowing, what we're doing is we're assuming that what we know, other people know, right? We're projecting our knowledge base onto them. And it manifests itself in a couple of different ways. The first one is what's called the principle of humanity. And that's our basic underlying assumption as humans, as people. We tend to walk around kind of thinking, well, everybody else is sort of like us. I don't know if basically the same is a great way for me to have described it, but really to think that they're like us. So if I like something, or if I know something, other people probably like that same thing or know that same thing, right? Like we're all basically the same. Other people are like us. So I thought I'd share with you a video about a study of kids and how we can test what they know and what they think other people know. So others knowing what we know. There's a nice Scientific American Frontiers video for you to watch. So I'm going to stop here in my little lecture. You guys will, in the playlist, you'll come upon this video next, and then we will resume this lecture after that.